Hello my dear students, welcome to Science Made Simple by Ms. Flops. Today our standard is 6E38.1. I can analyze and interpret data to describe the properties and compare sources of different forms of energy, including mechanical, electrical, chemical, radiant, and thermal. For a cross-cutting concept, energy and matter. Our concentration for today is all about the types and forms of energy. When you say energy, it is the ability to do work. Energy exists in many forms. Energy can be moved from one object to another. Energy can be changed from one form to another. And the conservation of energy that states that energy cannot be created nor destroyed. What is always present but never visible? That is energy. Although energy isn't visible, you can detect evidence of energy. So here are some forms of energy that you can see around you. For instance, this roller coaster. This is showing you mechanical energy. The energy coming from the fuel, the gas or the diesel that is being put into the car for this car to run. And that is chemical energy. Anything that you plug into the socket, you are getting electrical energy, and that makes your appliances or even your lamp or bulb lit up. Heat energy. And you have nuclear energy in here, and you have light energy. Let's see each one of these. Chemical energy. This is energy released by a chemical reaction. The food you eat contains chemical energy that is released when you digest your meal. So that's why when you are very weak and then you eat, then you feel that you have gained energy, and that makes you do work. That gives you the strength to continue what your activities are. It's simply because the food in there has stored energy, and that is chemical energy. Other forms of chemical energy are found in the wood, coal, gasoline, and natural gas. These contain chemical energy. Next, electrical energy. Electrical energy comes from electrons within atoms. It can be generated at a power plant or inside the battery and can power everything from remote-controlled cars to refrigerators. But remember, when you say inside the battery, there is the stored energy in battery is chemical energy. But once you use that battery, that chemical energy is being transformed to electrical energy. So for remote-controlled cars, so from chemical to electrical, and then these cars move, then you have now mechanical energy. Lightning and static electricity are also forms of electrical energy. So that means the lightning that we see, it has electrical energy. So that's why when you're hit or being hit by the lightning, then you will feel or you'll die because you'll become electrocuted because of that electrical energy coming from the lightning. Other sources of electrical energy include stored chemical energy in batteries, solar energy in solar cells, fuels or hydroelectric energy in generators. So if they are stored still, they are chemical energy. But once you use them so that your appliances, your lights will lit up, then that chemical energy in there is being converted to electrical energy. Next form of energy is heat, or often called thermal energy. Energy created by the motion of atoms and molecules that occurs within an object. Thermal energy exists when you heat a pot of water on a stove. So you will notice that when you touch this, the pot is hot because there's already that thermal energy coming from the stove. So all matter is made up of atoms that move faster when they heat up. So the molecules in any solid or liquid or even gas, when they are heat up, they move faster. So the faster the particles move, the higher the temperature. So heat energy is a transfer of thermal energy. And energy or heat energy always moves from hotter objects to cooler objects. We'll learn about this heat transfer in our next lessons. So we have nuclear energy. Energy contained in the nucleus of an atom. Nuclear energy is released when nuclei are split apart into several pieces or when they are combined to form a single larger nucleus. So this is quite complicated. This is not as common as we can see around us, but nuclear energy is also present as one form of energy. Light energy, or it is often called as radiant energy. Energy that can move through empty space. Why? Because the sun is the main source of radiant energy, including the stars. And the sun and the stars are outside in the outer space. So they can move through empty space because in the outer space there's no gas. And as part of like the medium of these waves or energy, you need a solid, a liquid, or a gas. But when you are in the outer space, then there is no solid nor liquid nor gas in there. So sun, which is the ultimate source of radiant energy, can travel through empty space. So the light given off by light bulbs and campfires are also forms of radiant energy. Solar energy is a type of radiant energy. So green plants use solar energy during photosynthesis, and in the process, they form the stored energy, which is called chemical energy. Most of the energy that we use on Earth originally came from the sun. So other sources of radiant energy include, but are not limited to, the stars, the light bulbs, and microwaves. And even our candles, fires, these flashlights. So these are sources of light energy. Then mechanical energy. Energy that moves objects from one place to another. You use mechanical energy when you kick a ball or turn the pedals of a bicycle. Other examples include water flowing in a stream, tires rolling down on a road, and sound waves from your iPod. Mechanical energy is the energy due to the motion, which is kinetic, and position, potential of an object. So let's go in detail about mechanical energy. So when objects are set in motion or are in a position where they can be set in motion, they have mechanical energy. And this mechanical energy can come in two forms. We have potential energy, which is the stored energy, and kinetic energy, which is the energy in motion, which we'll discuss in the next slide. But what is this potential energy? So there are 1, 2, and 3 types of potential energy. One is mechanical potential energy that is related to the position of an object. For example, when you see a cup on the table, it has mechanical potential energy because it stays there. But once you move it, it has the ability to move. A stretched rubber band has potential energy. This is called elastic potential energy. Whereas a book on a shelf has potential energy. Since gravity can pull the book to the floor, this is called gravitational potential energy. So the height and mass of an object affect gravitational potential energy. So this will be discussed in detail when we will learn about potential energy. So what are examples of potential energy? The energy in matter due to its position or the arrangement of its parts. So this has potential energy, this is potential energy. The apple here is this an apple or a cherry? Has potential energy. The food in here is potential energy, and even this has a potential energy. When we say kinetic energy, that is the energy of a moving object. So anything that you see moving, it has a kinetic energy. And these are examples of those. So let's see the difference between potential and energy in this illustration. In this case, when you see this one hanging up there and it's not moving and it has a height, this is potential energy. But once this object will fall down, so the moment it falls down, the potential energy was converted to kinetic energy. The same as this. So when this archer is trying to prepare to release the arrow, it has potential energy. But once the archer releases the arrow, and then the arrow now started to move, then the potential energy was converted to kinetic energy. The same with this person here. When the person is down here, it has no potential energy, but it has more of its kinetic energy. Once it moves up and reaches on the top and stops for a while, the moment it stops, kinetic energy became zero, while potential energy became maximum. So once this person goes down, the kinetic energy increases while the potential energy decreases. Once it reaches the bottom where there's no height, now potential energy is zero while kinetic energy is maximum. The same as this girl in here. Once she's holding this ball on top, this ball has more potential energy. The potential energy is maximum, while the kinetic energy is zero because it's not moving. We said kinetic should be, this is the energy in moving objects. So this is not moving, so this position, the ball has its highest potential energy, while kinetic energy is zero. Once this girl dropped the ball, the potential energy was converted to kinetic energy. So as this ball drops, potential energy becomes zero here, while kinetic energy will be maximum. So energy forms, these forms of energy do work that end up as motion, light, or heat. Energy is used to power manufacturing, light buildings, propel vehicles, and communicate messages. So what else do we use energy for? That's for you to answer. So if you want to practice more about the forms of energy, you can use these examples. For example, uses of energy. List 3 forms of energy in this picture. Are all 3 forms of energy needed to use this lamp? So in here, from the socket, it has electrical energy. Now the electrons flow to this wire that makes this lamp to lit up. There's light, so that's light energy. And if you notice that later on when you touch this light, you feel that it's hot, then there is now thermal or heat energy. What form of energy is spinning the turbines in order to generate electricity? So again, you have mechanical energy because it's moving, and now this mechanical energy will be converted to electrical energy. Okay, so you can answer the rest of this for you to practice what you have learned about forms of energy. So that will be all for today. Next video to watch, energy transformation.